Hello everyone, it's Mr. James here. Welcome back to another video. Today I am on Module 1 of Bluebonnet Math, going over how to understand different strategies of multiplication and division. So I have a few word problems here and I want to go through some of them just to see what strategies we can use best. Take a look at this problem here. It says that there are 4 plates. Each plate has 3 cookies. How many cookies are there in all? So right off the bat, just by reading this total, I can see that there are 4 plates. And it says each plate has 3 of the cookies. And we are looking for a total of how many cookies there are in all. So I'm going to use the RDW strategy just to really emphasize how to solve this problem. So this is going to be called the RDW strategy actually. So I'm going to set my paper up just like this. And I'm going to put the last W there. What do we know from reading the problem? We can see that there are 4 plates. 4 plates also means what? Groups. So I'm going to emphasize this as 4 groups. Okay? It says that each plate has 3 cookies. So we can call this the size. So 3 in each would be the size. And we are looking for a total. So I'm going to put a question mark here as for total number of cookies. And this is going to help us determine what operation that we are going to use. So since I know that there are 4 groups here, I will go ahead and draw those 4 groups. And I'm going to use circles just to demonstrate this purpose. 1, 2, 3, 4. Okay, now I have my 4 groups. I can also see that there are 3 in each. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Since we are looking for a total, I know I'm going to be multiplying. So since I'm going to be multiplying, I'm also going to write my equation for what it's going to look like, including the unknown. Since we're looking for a total, our unknown will be represented by a question mark. So I'm going to do 4 times 3 equals question mark. Since I know I'm doing multiplication here, I can tell I'm doing multiplication partially because we are looking for a total. And we know that in this case, our total is unknown. So since I have 4 groups of 3 here, that's one way that I've represented this out. And we're going to use skip counting as a way of trying to figure out the total. So since there are 3 here, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now I have 12. I'm going to use an array as well just to verify this information. So since I know there are 4 groups, I'm going to make a group of 4. 1, 2, 3, 4. And I'm going to have 3 rows. 2, 3, 4. 1, 2, 3, 4. Again, this is an array. And so when I count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice how this time, instead of skip counting by 3s, I skip counted by 4s. I believe that's an excellent way of trying to understand the different ways of multiplication. And one last way I'm going to just verify this is by using a number bond. So I'm going to use a number bond by simply putting a question mark right here in the middle since we're looking for a total. And since I know there are 4 groups, I'm going to make 4 of these bands here. Kind of looks like a spider. I'm going to represent that here with circles. Okay, and there's my groups of 4. Now I'm going to put 3 in each since that's the size of each group. 1, 2, 3. 1, 2, 3. 1, 2, 3, 1, 2, 3. Now we can use skip counting as a method to find our answer. Since this is 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice we got the same answer each time we represented this. So now I can officially fill in my equation. This will be 4 times 3 equals 12. Okay, so to finish my problem, I'm going to go ahead and finish the question. It says, how many cookies are there in all? My answer will be, there are 12 cookies in all. Okay? And this is how we use the RDW strategy to solve our problem. I use 3 different drawings. You can use partially 1. Okay? Let's try another question. This one may be a little different, and we're going to use another strategy to solve. It says that there are 9 boxes. Each box has 4 pencils. How many pencils are there? Okay, let's go ahead and set up our paper here using RDW. I'm going to put the R here, the D here, and then I'll put both W's here. Okay? So after reading the question, let's identify what was important. It says that there are 9 boxes. We know that boxes can also mean what? Groups. So I'm going to write groups right here. It says each box has 4 pencils. So each has 4 pencils inside. That means that that would be the size of the groups. It says how many pencils are there. So now we know we're looking for a total, which also does mean that we will be multiplying. So let's write out our information. We have 9 boxes, which is also equal to 9 groups. Okay? Representing that there. It also says that each box has 4 pencils. So 4 is the size. I know that that's the size because it says each has 4 inside. Okay? And I'm looking for a total. So I don't have a total just yet. So I'm looking for the total number of what? Pencils. Okay? So there we go. Let's go ahead and draw this out. This time I'm going to use a strip diagram to show you how we can represent our multiplication problem. So I'm going to draw a strip diagram here. I like to do mine like this, but everybody can do theirs differently. So I have a box. I'm going to separate this group into 9 sections, or as I like to call it, 9 groups. 1, 2, 3, 4, 5, 6, 7, 8, and then that makes 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Always double check. Okay? Now, since I'm looking for a total, I'm going to put a question mark to represent this whole strip diagram. Okay? And I need to identify my size again. So what's my size? 4 pencils. Okay, so now I'm going to put 4 pencils in each of these boxes. 1, 2, 3, 4. Notice every time I put the number of pencils, I'm going to write it underneath. 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. All right, so now we officially have our representation here. And we ended at 36 pencils with 4 in each. So our question mark, our unknown, would actually be 36 pencils. Okay, so my equation here that I originally started out with was 9 times 4 equals our unknown. Okay, so since I went ahead and verified that, now we can really see if we're correct here. I'm going to use one more strategy just to make sure I'm correct. This time I want to use skip counting, but this time I want to do it by 9s. So a way that I can do that is by simply drawing 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's my 9. Now let's go ahead and skip count by 9s 4 times. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 19, 20, 21, 22, 23, 24, 25, 26, 27. All I'm doing is counting the dots. 28, 29, 30, 31, 32, 33, 34, 35, 36. And 36 is my final answer. Okay, so my final answer will be represented by 39 times 4 equals 36. So now we can answer the question. How many pencils are there? There are 36 pencils in all. And there's the answer to my question. Okay? So I'm feeling a little bit more confident using different strategies. We have a strip diagram, we've used skip counting, and at the top we've used a number bond. And I'm also going to go ahead and fill this out here to make it 12. And then we also used an array. And lastly, we used groups. Okay? So that was some multiplication strategies that we used to solve problems. One-step word problems at that. Let's try some division strategies here. Now we're talking about oranges. This question states that there are 12 oranges shared equally among 3 baskets. How many oranges are in each basket? So if you look at the problem, let's identify this. So first things first, we're going to set up our RDW placemat here. So this is R, cricket line. This is the D, W, and W. All right. So now that we got that set up, we can go ahead and start solving. So it says that there are 12 oranges shared equally. Okay. So shared equally typically means that I'm going to be dividing because I'm partitioning something up into groups equally. Okay. It says in 3 baskets. What does baskets mean in math terms? This means groups. So I have the number of groups, but what am I missing? It says how many oranges are inside of each basket. We are missing the size. This is our unknown. That's the size. So we have a total. So I'm going to write that here. Total of 12 oranges. Okay. What else do I know? There are 3 groups. And what do I not know, which is my unknown? I do not know the size of the groups. So what are you going to do? I am going to be dividing. I'm going to put that on here as well. Divide. This is my mental note here that I'm going to use this operation. So we can set our equation up as 12 divided by 3 groups equals our unknown. So in other terms, this will be the total divided by groups equals the size. And that's what we're looking for. All right. Now let's go ahead and solve this. I'm going to use 2 different strategies to help you solve this type of problem. And I'm going to start with equal groups. So I know that I have 3 groups. So I'm going to draw 3 groups. 1, 2, 3. Instead of putting 12 in each, I'm going to put 1 in each until I get to 12. Just like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. How many is in each group? 4. So that's the size of each group. Always make sure that you have the same exact number inside of each group. And if you don't, then you've made a mistake. So you always want to go back and double check your work. Okay? So we can also use inverse operations by using our multiples of 3. So if I do 12 divided by 3 equals blank, I can also set this up and flip this as 3 times blank equals 12. This is what we call inverse operations. Now we're getting into the multiplication aspect. We're using the sister of division. And if I do my multiples here of 3, 6, 9, 12, I see that I have 4 numbers. So my answer here would be 4. Okay? It would be 4. So this is one way that I like to use division as a strategy, using the inverse as well as using equal groups. So my official last equation will be 12 divided by 3 equals 4. Now we can officially answer the question. How many oranges are in each basket? There are 4 oranges in each basket. And I'm going to put that here. All right, so now we have officially done a division question by locating the size when we have the groups, and another type of question that we will